Alright, look like tonight we're doing a public live because I don't want to wait like 10-15 minutes to reset this thing. So if you're inside this is actually a private class. But somehow you're inside. Boom. Here comes the link, people. Boom. Alright, so let me know. Let me see the names in the live. Let me see the names on the live. You all hear me properly? Let me make sure this. Normally when all these kind of things start to happen, volume doesn't be working good. Okay. How much viewers we have? I think this live could still be public. But what we gonna do? What we gonna do? Great. Should be unlisted. It is unlisted. But I did a public live yesterday. So things happening that way. Uh, 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 chat. Check here. It's unlisted. Okay, and I see the chat happening in the next side. Use the link in the use the link because I've seen some people in the older live stream that just so yeah, I sent out a link around 2 minutes to 7. That's the wrong thing. Click this link so that that notification pop up on YouTube. Maybe one of these days I'll do a public class. This on Tuesday. But I really don't want to do that tonight because there's a lot of work we're trying to push. And when the class is public, it could be a little distracting. Answering all the questions. So, alright, people. Trigs, trigonometry. So, a little recap. We are 67 battery percent, so we should be ready to go. I did put on this, just give me a second to just set up this. I need to use this live stream here because my chat not loading. Alright, so Matthew, good night. Marcia, Matthew, Sekayong, Seka. Melanin Poppin, Daryl, Sajda, Ilan, IBTU, Mary Gomez, Giovanni, Alvarez, and Christian. Good night, everybody. Let me get the show on the road, everything running. Good. Recap. We talked about these kind of situations. We would have talked about corresponding angles. We would have talked about vertically opposite angles, alternate angles. We would have discussed those things because we discuss things on here. We would have talked about the Peter Papa. We would have talked about uh, 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 Pythagoras theorem. C squared is equal to a squared plus b squared. We would have had a lot of fun in that. That last assignment that we do, wow, good work. I mean, it's only a certain amount of people could fit on the top students list, but there are a lot of people who got over 80%. It was handled well. Right, so kudos to those who did really well on that. We seen some improvement. I hope the same thing happens for this assignment here this week because you see topics. This assignment going to be a little problematic. So good luck with that. Good night, Mary. So I'll be out for a few minutes just to drive home from work. Okay. I hope by the time we finish the recap you're on the inside. I in get my marks yet. How did you send your stuff late? Every mark was sent and written, and we also do. What we also do again? Oh, right angle triangle again. If you have a right angle triangle. and you have like theta here, and we have like opposite, adjacent, hypotenuse. So this is just recap to make sure we everybody on the same page. We did like sine theta equal opposite over hypotenuse. So cosine theta equals adjacent over hypotenuse. Vibes, and tan theta equals opposite over adjacent. So we did all of these things. Yesterday I sent in mine. That's considered late. Well, yeah. Anything after Sunday is late. Anything Monday morning stand a low chance of getting corrected. People who send in late on Saturday after like 8 and 9 and thing, them fellas is still deal with anything. But remember, everything had a run on a time too. So alright, so we did that, and also in the free video that I posted on the channel, we would have done some area formulas. So I'm hoping that you watch those. I forget to send a reminder in the group to watch the free videos, but you're also supposed to get a notification. Let me see by wise in the chat if you watch the videos on area very quickly. So you have height, you have base. Can you tell me some of the formulas to get the area of a triangle? It is about the big pole. If we have like a scaling triangle here, A, B, C, if we have a next scaling triangle situation taking place here, like we have, let's say we have theta, we have A, B, and the angle at C. Or let's use the one in your formula sheet. Let's call this BC and the angle at A. Yeah. So people watch those videos, right? Great. So the area for the first one is what everybody knows since primary school. If you don't know this by now, you need to get yourself a little hard clout and thing. Area is equal to half base by height. The next one is what people really care about. This one that doesn't really pop up that often, but kind of disgusting. Where S is equal to the perimeter divided by 2. And then the area would be equal to, I think I actually make a mistake in this video and I cannot feel to take it down. I just say I make the mistake in the comments. And something I was adding and I make a mistake. So area is equal to the square root of S by S minus A, S minus B, S minus C. So this is the weirdest one. Right, so I never get trouble with any link ever, and this one gave me trouble. Yeah, this link would give trouble because I went public with the video just now. So, and when I refresh like about 10 times, because if I go back unlisted now, people will still have the old link. So they need to generate a new link, and they'll get trouble. And the last formula is area is equal to half AB sine, alright, we're using a different formula here. Half BC sine A. So if anything in this recap you don't know, you need to go back and learn it. All these kind of things, all these situations with lines crossing and stuff, we did that. We talked about even angle, how much, why I can't say this way, how much the angles in a straight line add up to, we talk about that. So we talk all about Pythagoras theorem, we talk all about the SOHCAHTOA stuff. We talk all about these three things in 3 short videos that you could go and take a look at. Now it's time to move on. Now it's time to go deeper. Somebody say go deeper. Now it's time to go into the part of trigonometry that comes in the next section of the paper. I wasn't planning to do this, but you know what? After that assignment, I feel like people take it to the trigonometry, so that we see how they were doing this assignment, right? Alright, so let's just do a quick touch on what's going to happen tonight. I hope this girl reach your mind now. So you okay? Your energy usually on 100, but you're looking like it's on about 50-ish. Sabrina, don't miss nothing, you know? Sabrina, don't miss nothing, right? What happened? I just wake up and I rebooted. My energy was drained today, so I rebooted, and I didn't go gym this morning. Um, what are we doing today? What are we doing today? So we're gonna start off with the rules: sine rule, cosine rule, cosine rule, sine rule. But don't worry, we could still cause it at a 50%. 50%. 50% Cohen is still good among that percentage. Did I mention that we're doing this? Yeah, we're doing that. So you're doing sine rule, cosine rule. Forget them area formula things. I have 3 videos and I take a look at that. If I'm seeing problems and in the assignment, I'll swing back at it again. And then we're going to start to look at uses: angle of elevation, angle of depression, angle of depression. Anybody here going through the angle of depression? Depression is such a weird thing, I think. And bearings to the people there. That the bread van there, they know things is bearings. So which one of these topics you all find really challenging? Yeah, yeah, Christian, I only started going gym like about 3 weeks ago to keep the energy high. You miss tan. I miss tan. I miss tan, man. Tan me. Tan what? It are no tan rule. It are no tan rule. Thank the Lord. Thank the Lord. Oh just back. Oh just. Let's go with the oh just now. It are no tan rule, right? Bearings is a stress. Cosine and sine rule is stress. Alright, so let's explain what these things are. Now, how it comes in the exam is that they will bring this and you'll need to show your knowledge of that and that. There's also one more topic. I will mention it today if we have time. One more topic in Trigs. This is 3D trigonometry. Most schools, when I was doing a survey this year, in the live before exam, like 90% of the people knew nothing about this. So most school teachers, like, they don't even reach to this or they don't teach this or something. And that is out of 700 students all over the Caribbean, right? So that is BRC, 3D trigonometry, and every now and then they just pop in a question and people just be like, angle of depression. Angle of depression. So we can talk about this. Let's go. Sine rule. Sine rule. So there's no tan rule. There's no tan rule in C-Sec maths, right? There's 3D trigonometry here. Whereas we're going through this with depression and bearings and right. So the sine rule. I wish it had something to draw triangles here because there's a little problems with this. Boom bam. Right. To me, out of all between the sine rule and the cosine rule, the sine rule is the simplest, quickest, sweetest, bestest, easiest one to use. Sine rule it's just nice. It's just nice. Remember, we use capital letters to label the vertices of a triangle, the points on a triangle, right? Stay with me, Alice. Stay with me. I've seen 36 people normally. We have about 50 something people. Like if my energy is higher, the energy drop too. C, A, B. Democrats. What is that? Oh, sorry. Political news bouncing up here. So you need to know this. You need to understand what's happening here. Each line, each side is opposite. So like if this is your vertex here, that is C. This is your vertex here, that is B. Alright, so how does the sine rule come into play with this thing? Let's make him a little smaller. You are trying to select this whole thing here. You go up in the corner so and smile. Alright, cool. Smile for the people. Right, so the sine rule looks like this. It says that if I take the sine of A and divide it by the side A is the same as if I took the sine of B and divide it by the side B is the same as if I took the sine of C and divided by the side C. You may see it like this in your formula sheet. It can be differently, it can be expressed differently as well, you know. It can be expressed differently. Let me show you. Sometimes you might have A over sine A, which is just the inverse, would be equal to B over sine B, would be equal to C over sine capital C. So, by itself, this rule looks kind of whack. What does it do? Let me explain what it does. How can this help us in our triangle, playing the triangle games? So let's say we had a nice little triangle here. And this triangle has three sides like all triangles. And let's say this side is 3 centimeters. And let's see this angle. What is looking like earlier? Like you say this is 70 degrees. And let's give another angle. Let's give another angle. This angle here will allow him to be a nice solid 40 degrees. Great. And let's start labeling. Let's call this A, B, C, and we'll stop right there. So this is the angle. So something like this can come in your exam. No, it doesn't come straight out like a question like this, boom, find something. There will be a little, it'll be buried deep in angle of elevation or in bearings. And when we start to touch the angle of elevation and bearings, you'll see how it pops. But we're just explaining it right now. Catch the drift? So you're given an angle, another angle, and a sine. And the question will be basically trying to get something out of you. It wants something from you, as all questions do. Find the value of BC. There it is, the question complete. Then let me know, this is what I want from you. I want to know the length of BC. Now, just to be clear, what is BC? BC is this side over here. Let's give him a nice little purple highlight. And this is a really colorful triangle there. So that's BC. Here is where you watch this and you see, I'm going to use the sine rule. Now I'll explain how you begin to know these things offhand. But for now, we just do the question. So what you'll see to yourself is, okay, they already labeled it A, B, C. Nice. I'm going to call this side over here common A. Let's put that in green because you know there's colorful triangle here. A, and let's put this side across here in C because that's the side that we know. Now we're gonna explain how you're supposed to see this and deduce this in an exam just now. But pay attention to what I'm doing. So what you say to yourself now is self. By the way, when you deal with the sine rule, you don't deal with the whole rule. You always take away one section of the rule. Right? You always deal two parts alone. Let me show you what I mean. So you'll see I have C, and I have the angle at C. So I'm going to say sine of C over, let's put it the other way around since I'm trying to find a sine. I'm going to say C over the sine of C. Don't worry if you're not catching it right now, we're going to explain again. Must be equal to A over the sine of A. C over the sine of C. And I have something very important to say right after this question, right after we do this question. A style in studying. Maybe about 5 to 10 people message me the same problem within a month. Getting problems in studying. So I've been thinking about it and going through some of my stuff and I have an answer. C over sine C is equal to A over sine A. So this is where you use your substitution technique. This C here stands for the common C over there. So that is 3 centimeters, right? Sine C, the angle at C is 40 degrees. Sine 40 degrees. You're starting to see how the substitution will and give us an answer here. A is what we're trying to find. A is the BC. So I'll write BC. A capital A is the angle at A, which is sine 70 degrees. Right? I'm going to put it sine 70. So at the end of it all, this is going to be BC is equal to this multiplied by that. Why is in the chat if you understand all of that? So everybody was quiet for a very, very long time. Why is in the chat if you understand what is happening there? Anybody catch anything there? I'm going to repeat it, right? Why is in the chat if you understood anything there? Wow! I feel like this wasn't explained that hot and I've seen some whites. Alright, so in the end, this is going to be sine 70 multiplied by 3 over sine 40. So I'm just multiplying this by this. I am. So sine 70 multiplied by 3 sine 40. So let me report my little calculator here. Sorry. No, I want to continue my current version. Pop up there. Look for the calculator here. Open that. So boom. Move this up. You know what? What we're doing is this, people. Copy. Paste it over here so people can see. That's what we're doing earlier. Sine 70 multiplied by 3 sine 40. So on your calculator now, you're gonna be like, how we doing this, fellas? You'll see, alright, sine 70. By the way, make sure you see that D there, no R, because it must be in degrees, not radians. Multiply by, there's a fraction, so I hit down this fraction thing, 3 over sine 40 earlier. Sine 40. Press equal, bam, that's the answer there. That's the answer there. Straight up. So the sine rule, to me, out of everything in trigonometry, the sine rule is the cleanest, quickest thing to do, maybe other than Pythagoras' theorem. Let's do a next example. In this next example, I'll be explaining how I know it's the sine rule I'm doing. Who banging that way? Centimeters. 4.39 centimeters. Alright, so there we go. Oh gosh, you take it away from my money card. Zan like to bang everything, the man. Really believe in this hitting thing. Drums, when you reach in church, you go on that drums day, nobody could take him off of that drums after church. Man had to cry to woman. PQR angle here. Let's give this angle 50 degrees. Let's give this angle close to 90. Let's make this about 80 degrees. Let's see, this is 7 meters. So can you use one to find angle and the others to find side? You mean cosine rule will sustain? No, you could use the sine rule to find either angle or side. And the next example I'm going to use that. That's a good question. So can you give us some ways to identify? Yes, we're going to talk about that now. Boom. Right. So find QR. Find QR. So in your mind now, you're supposed to immediately try and look for QR. Boom. Now there's a way to identify cosine rule. The first thing I am always looking for is the cosine rule, but I always teach you sine rule first. Maybe I should rethink that, right? But the first thing I always look for is the cosine rule, because cosine rule is sandwich and an angle in between. But there's the way to know the sine rule. Always round off to 3 significant figures by default, Marcia. Never 2, always 3. Always 3 significant figures. Alright, so unless otherwise stated. So you see this side here? I'm given a side to find and the angle opposite. And now I have an angle opposite and a side here. So anytime you see that kind of flip flap thing playing off, here I'm describing this flip flap thing. Anytime you see one angle on the opposite side and another angle on the opposite side, and one of them missing, one of those things missing, sine rule. Time to activate your sine rule. Time to label that soldier up and bring your sine rule in the game. Anytime you see one angle on the opposite side and you see another angle on the opposite side, and that is what we're talking about, that is the things in question, time to bring your sine rule into the game. So we see that occurring here, so the sine rule need to come into the game. So now we're going to label. You could use the labeling they have. If you're not comfortable with it, you could relabel this A, B, C if you stick on the formula, you know what I mean? But I'm going to use the labeling they have, right? So P, common P, R, I don't, it's not, wait, sorry, we don't know nothing about this R, and we don't know nothing about this side. That was a learning moment earlier. So it's not a Q, common Q here. So now I can be like, what is I trying to find? I'm trying to find P. So I would start off with the sine of common P, or I can say QR, so they know I'm talking about that. So penmanship way better today. No guessing and squinting. Yeah. Thank you. You know, I've been putting in the work. People. Sine QR is over P, or it could next thing penmanship just as bad as just like start to get accustomed to it now. Didn't think of that. Sine of PR, so I put PR here over Q. So right. So when I do my substitution, this is really the sine of the side I label P, which divide sine, sorry, not sine of P, sine of, what am I doing? I hope nobody was taking notice. I get distracted with the complement D. Sine of P over QR is equal to the sine of Q, the angle, remember the sine is for the angle of Q over, let me just verify that. The sine of P over QR is the sine of Q over PR. So yeah, we good there. So now it will be like sine P, the angle at P, 50, lost. I was writing, so sorry about that. Sine 50 degrees, sine 50 degrees over, so this is sine of this over that, P is equal to sine 80 degrees over PR is 7. Now, what different from the last time with this? Well, it's not a problem. It's not a problem. What different from the last time with this is the P is underneath. And this happens underneath because when you're trying to find the side, it's better to use the formula like this with the sine part underneath. So you have the line on top and you have the sine of the angle underneath. Now I did say this is the deeper part of trigonometry. I'll do another example after this. So for those who still kind of spinning a little bit, we'll do our next example. So the side part I happen to put it underneath here, which means to find this missing spot could be a little problematic. But all you need to do, if you're in this scenario in exams, in any kind of question, let me show you the trick you want to do. Flip this. Put the P on top, put the sine 50 underneath. But if I flip this side, sorry, yeah, I kind of losing your writing it. 7 over sine 80. I need to flip the right hand side as well. So I don't know how to get the first line like before you substitute. First line. We're gonna do one more. And then it's time to try. Remember, I say after I do this question, I had to explain something in mathematics. I say it like about every 5 classes, but I need to bring new light to this because people doesn't believe me. multiply by the sine of 50. So all I do now is just bring across this just like before to get the answer now. I guess what the answer. Bring up my calculator. Calculator. I try to find sine of 50 multiplied by 7 over 3. Delete 50 multiplied by, this time it was 7 over sine 80. Why did I say 7 over 3? Sine 80. Boom. So that's 5.445 meters. Now, what's something here? Every time I get a side, anytime I get anything in form or somebody say do form, anytime I get the value of a side, I always check it back and see if it's looking good. So this was 7, and this is 5.4. All right, that's looking good. Some people do that. Some people will get 600 here and go and write 600. All right, that's 600. But this is 7. So always double check your answers to see if it's making sense. You know, that's the thing. Okay, before I go on, maths is one of those things you need to try to, I say this all the time. The learning comes by trying. I had a massive argument with this girl in my class in school. One of my students, I love this student, a good student, nice student, but she doesn't like, she's the type of student who sits down in class and just takes down notes, right? Good notes waiting for me. She doesn't even attempt the question that much. She watching on the board, wait for till I do the solution and take it out. I get vexed and I start correlating. I say, I don't care about your notes. You see how you use right? I don't care about your notes. And I start to go off and think as a teacher. But it was an important lesson I'm trying to tell her. The most important thing in math is trying the question for yourself. That is where the learning comes from. So you see how some of you all may be having a little struggle here. I want you to try this now. You may be having a little struggle here. I'm going to do the example one more time. Not 4 more times, Christian. One more time. And I want you to start. This girl and a few other people in class, because of how they learn maths, because how the environment they brought up in, how people used to tease them and things, to do a question and get it wrong, it's like, oh, they don't want to be caught in that position at all. But that's the only way you learn maths now. That's the only way you learn. From actually trying the question, and if you get it right, you know you learn, you know you have it. Or if you get it wrong, and begin to correct the mistake. That's the only way you learn maths. Some people not getting that. I'm doing one more question, people. All right, so and afterwards you all will send this question in the group and we'll begin to look through the mistakes and see where we can learn. One more thing on that. In my class, I work along with plenty scholarship winners. You all know before I started doing online class, this was the number one thing. 2 things I used to do: work with students who fail maths a lot and get them to pass, and work with students who trying to get a scholarship, private tuition, go to their homes, work along with them in maths, physics, chemistry, everything, trying to get a scholarship and make them get the scholarship. The number one thing we do all the time is exams. Because reading over, making notes, learning stuff, me teaching all my fancy teaching methods and things, not as important as actually trying questions and going out and see where's the problem. This is, take that for how you want to take that, people. Let me go back with the ABC here. ABC. And let's call this side. Remember, this example is going to be a little different. I'm going to say this side is 5 centimeters, and I'm going to give you a next side now. I'm going to say this side is 7 centimeters, and then I'm going to say this angle is 30 degrees. Now I'm going to ask you, what about this angle over here? What is theta? So what is theta? This is still a sine rule question. How do I know? Because I didn't say I switched topic yet. So obviously we still at sine rule. No, that's not what I know too. How I know. Alright, this could be a little problematic if I leave it as this theta. I don't want to do that yet. Let me put theta on this side. How I know is that you have a theta here and you have an angle given there. You have an angle a side given here. So you have an angle. I want to be very clear when I'm talking. You have an angle and you have the side opposite to the angle. Next situation, you have an angle and you have a side opposite the angle. Anytime you have that pairing of angle opposite side, that is time. Tell her about my feelings. Oh gosh, Christian, you can't send pics. Christian, you need to fix that situation. As you always said, get things wrong here. So anytime you have this situation in angle and sides, you want to take out your sine rule. So you just begin blindly with your sine rule. So like if I give you a question like this, you just start off blindly with your sine rule. Be like sine, what is the angle? Does that one at B? Alright, sine B over, you could say the opposite side and label it first, right? So don't put the 7 first, let's just put AC. You understand what I'm doing there? Then I'll be like, okay, next part, sine C. I know that we're going to be 30 here, but just playing C for now, so that they know I'm using the formula over this side. So this is AB, that side is AB, understand? AB. Now, I could have labeled that side anything I want. Like, for example, we know both sides, but the angle here is theta. But like if I didn't know this side before, I would call this side common C, and that's what I'd be finding. Catch where I'm coming from. Alright, so now you're hitting them the substitution. Sine B. Oh, you don't know what B is, so sine theta, that's great, over AC, AC is 7, is equal to the sine of C, sine of 30 over 5 over 5. And now sine theta is equal to sine of 30 degrees over 5 multiplied by 7. Yeah. Wait to do that over the first line. I get it now. Wait. Alright, so let me say it again. You start off here with this, because this is the formula. You don't want to put any numbers or angles in this. You just want to set up the sine of the angle over the line. So sine of your angle theta, or B, angle at B, over the line AC. Sine of your angle here, C, 30 degrees, over this side, AB. You do all these substitutions now. Theta is at B, AC is really 7, C is 30, and this 5 goes across here. So now you will be like sine theta is equal to sine 30 over 5 multiplied by 7. You put that in your calculator. We're going to do a little inverse thing here. Get excited about that. We're going to get a chance to do inverse stuff right now. Calculator time. Boom. Bam. It was sine 30. It was a fraction, so I'll start off with the fraction symbol. Sine 30 over. How you get the formula? How you get that formula? We always knew that formula. Sine, that's the whole, that's the point there, that's the point. The formula is sine A over A is equal to sine B over B is equal to sine C over C. That's the formula. 5 multiplied by 7, it's kind of hiding, but it had multiply by 7 right in the corner there. Boom, 7/10. If you know what that 7/10, you can press this, 0.7. Does that make sense? Yeah, that makes sense. 0.7. This is not the final answer. That is sine theta is equal to 0.7. So now theta, you understand? We're going to get a chance to do the little sine inverse trick. Sine inverse of 0.7. I just try to squeeze it in there. I'll imagine a 7 in the corner. This is 0.7. I don't want to get rid of the calculator yet because it's time to do that. Shift. Sine inverse. You remember how to get the sine inverse, right? 0.7, close that bracket, boom. 44.4 degrees. 44.4 degrees. And that is your answer. Does that make sense, boy? Yeah, because this looking like 30, this will look a little bigger. 44.4. Alright. Alright, I can roll with that. I can believe that. Theta is equal to 44.4 degrees. disappear calculator. Alright, enough talk. Time. Some people get 70. Some people get 44.4. Time to do a question by yourself. This is the moment of truth. You're sending your answer in the group, right? So, ignore them screaming and thing in the background there. As I said last week, this man just pick up a screaming thing. Screaming is the new way of doing things. P, Q, R. Time to put in some stuff. Let me see. I'm just looking like. You see this? Let me see this. I got 53 degrees. And let me put in some stuff here and see this is about 40 degrees. And let's make this X. And let's make this 10, a nice solid 10 centimeters. And if I say find X, all right, go ahead. Go ahead and find X. So you want to start off with a nice little formula first. Hopefully you are taking out notes from before so you have something to compare with. I'm going to the chat crying about it. Send the answers in the group. Alright, let's see how things looking in this here, boy. Matthew lost. Let me see if you get any answers at all. Matthew right up to where you know now, boy. Red group. No, red group just talking about the video. Nothing yet, nothing yet. I'm going to start off here. I'm going to start off people. We have 36 people on right now. So we find an excellent. So let me just put this little highlight so I know this and this. And I'll put a different color highlight here because, you know, I can. And I'll put a little orange to represent this and this. So it's the sine. What am I trying to find? I'm trying to find a side. So I'll keep the side on top. I'll keep side on top. In fact, I'll start with this side since I make it easier for myself now. PQ. Because remember the sine formula? Let me start off with the sine formula. Just for those who A over sine A is the same as B over sine B. You can do it like that. Some people getting 12.4. Send your answers in the group. And then I could come now if I want to, if I don't want to go through all that scenario and label up my own things. Oh, by the way, can I use capital A there, boy? Boys! A and B. Now, that's like the third little small mistake I made as I'm doing something there. A. As, these things I always note like how well I'm functioning. A, capital A, capital B, B. Understand what I'm doing there? So now I can make my substitutions nice and quick. If you want, you can do it like that. A is x over sine A is 40 is equal to B. B is 10 over sine B, sine 53. Right. And then x would be equal to 10 over sine 53 times sine 40. I can't send pics. Check red group. So red group. Only red group sending things. What going on blue group? Alright, no, blue group sent something a long time ago. A long time ago. That's Daryl. Daryl for the people them. Cool, cool. I feel he get correct there at 8.05. Red group. Red group have 1, 2. Sabrina in a nice place. She's in a nice place. QR is already right. QR? Nah. Not in a nice place. You're supposed to have QP on one side. That's a one mistake there. It's supposed to be QR and QP. Right? If you do it like that. Nicholas, well done. You do all kind of flipping and thingy, but you make it in the end, you make it. And good, Danny, good. Wow. So we cooking now. I need to see more people from blue group. I need to see more. I need to talk to the admin about this blue group, and I find blue group dropping 8.05. What we dealing with? Centimeters? Centimeters. That's the final answer when you put that in your calculator. So you're not getting any problems with that in your calculator, that is. Let's try another one. Let's try WAPS. Let's see, this is 4, and I'm not going to give it any labels now. So you have to create it, you have to generate your own labels. Let's say this is 30 degrees, red group just send the next thing. I see you. Let's say this is theta. And this over here is, let's say this is 7.8. Find the size of theta. I didn't put no units for the sides, but I small thing. So go ahead, find theta now. Quickly as possible. As quickly as possible. The 200%ers came from blue group there. And that is awesome. And that person get 100%, like that's the third time I think that person get 100%. So whoever you are, 100% the person, you know yourself. Keep up the good work, my youth. I now get it. I had it. I sent my thing long time. Yeah. I see it. Red group, boom. Red group, please don't tell me this is this question you just sent in here already. 8.5. So Hannah come true. Felicia come true. No, it look like it's 8.5. But some people have 8.04. It look like it's 8.05. You rounding off. Maybe you. And that's getting this problem. Some people are rounding off stuff too early. Like you work out this as a number, and then you try and work everything in one block, like this. That way you have less rounding off errors. But I know way more people writing than this. I need to see more pictures. I left followed up my phone with some pictures there. Followed up my phone with some pictures. Who feeling nice for Christmas? I want to get an iPhone 11. People across the Caribbean streets. Dee 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 dee. Da 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 da. Do, 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 do. Now we see you coming in first in this question here now. Hmm. Let's see when I'm bringing first. Cosine, Marie, Sharon, Aaron, Katrina, Rory, Jamar, Standa, Callista, G, Carrie Ann, Mary, Adam, Melissa, Camille, Marcia, Lestra, Amanda, Zell, Kassan. Are they sending pictures? Sherry Ann, Abigail, boom, somebody just sent something. Red group, red group, red group, Sajda. Kill off. Well done. 77.2. Blue group just sending to 77.2. Even if you don't have units here, it will always be degrees here. You understand what I mean? Because look, I even have degrees there. So you'll always be working in degrees for mathematics. Your angles will always be in degrees, unless you're doing mathematics, you could have radians coming in the dance as well. What? Like you came from the mosquito room to say hello from the other side. So blue group and red group both sending something there. Let's see the others. Here comes blue group again. Blue group, Matthew, 31.2. Okay, let's see where this could have went wrong. We caught the sine of theta over 7.8, the sine of 30 over 4. So that's correct. You multiply. You're supposed to get a point or something, I think. You're supposed to get a decimal and then not Q, eh? This is not Q, Matthew. This here is not Q. This is theta, so alright, like this. Got a fancy little old kind of wire thing there. So yeah. Theta. Okay, so let me just do this quickly. I know the pictures will start to pop in now. So I would be sine theta. I would label him. Label. A, A. B, B. Catch the drift there? Nobody care about C because you know there's only two we need all the time. I'm trying to find B, angle at B, so I'll start off with that. Sine of B over common B is equal to sine of A over common A. Good. Great. Feeling is very good about that. Now I can do my little substitution. Sine of theta, treat theta with respect, over 7.8. Don't go and make theta look like anything but theta. Everybody needs to be treated with respect. Sine of 30 over 4. And then sine theta is, yes, theta looks a little weird, but you know, still treat them with respect. Even if someone looks a little weird, it still deserves the respect. Even if someone is doing weird things, you should be kind to theta. So sine of 30 over 4 multiplied by 7.8. Because sometimes you may be doing weird things and you want people to treat you with respect too. Sine of 30. Oh gosh, that's looking ridiculous. Sine, I hope all this talking are already correct thing. Sine of 30 over 4 multiplied by 7.8. 7.8 equals. Now you notice again a fraction, right? And I think I spotted that fraction. I spotted that fraction in several places. 0.975. Where did the 7 go? 0.975 is sine of theta. So I would be like, theta, is that really so? Okay. Theta is equal to the sine inverse of 0. Because I need to get the sign across. And anytime something goes across that equal sign is a inverter. So it was added and you happen to step across the equal sign, you turn to subtraction. If you are multiplying and you step across that equal sign, you turn to division. If you are sine and you step across the equal sign, you turn to sine inverse of 0.975. There's a 5 in there somewhere. Sorry, Sabrina, I know you're taking notes and marking my handwriting here and going and send my results afterwards. That thing. And 77.2 degrees is what we get. So let's see, I think Marcia got 1. We had some little problems there. Red group loading up. Danny, delete this one and delete this. Is Alia, I loving it. That looking well done. Nicholas. Nicholas went to 4 decimal places just to stand out from the crowd. And it's good. Here comes Danny with a sip of positive tea. Well done, Danny. Wow. Red group having a party across there. Let me see the back to the chats. Oh, the live video disappear here. I hope it's still there. Thanks for the tea. Thank you for the tea. The videos are taking a longer time back this video. Right. 37 people on tonight. Yeah, like tonight is a rough night, boy. So you're not finished. So can you do another one with a fine in the leg? Yes, I can. That's what I have. So you flip the formula when you have to find the angle. Ah, that's big. That's a big point you hit there. Yes. You see, you is the boss of the formula. The formula is not the boss of you. So you need to gangster that formula. So I don't have iPhone money. For nothing I get in this. Daniel Martin, don't worry yourself, Daniel. There's more questions to come. There's more questions to come. Go blind in it. Let's make this one very easy in terms of how we write out everything. ABC. Let's see, I'm giving this angle over here 60 degrees. Let's do some solid nice angles, 60 degrees. And I feel like using this angle over here and calling this one nice 50 degrees. And I would be like 60 degrees equal to 7. The 7 we're going to use. Now we use 9 centimeters. And across here, I'll be like find AC. So find the length of AC. Go ahead. I don't want to see this topic ever in my life after this. Christian says the damnedest things. Mercia after there is where I was again problems to read that sentence. It was getting error. It was getting error. I was getting error. Cool. So we finding AC. That's this side across here, right? So we could go ahead and call that side B, common B, for our own devious purposes, common B. This side across here is common A. So I didn't get that. You didn't get that? Okay. Try again with this question. That's not 9 and this is E. Try again with this question. I'll be paying close attention to what you're saying in the group. So B, start off with the formula. We trying to get B, so obviously I'm going to put B on top here. That would be nice. I feel that's a nicer thing to do. I'll put B on top, B over sine of capital B is equal to C. Already learned C. Now we're not going to C again. We really going to see a hard time. A, notice is mostly A and B we're using it. Note to self, sine A. Sine A. Maybe a calculator in radians. Check and see if you have like a calculator screen. Have a little D mark on top there. If you have an area in a monkey pants there, you need to press the reset button. It needs to be in D, because D stands for degrees. Your calculator can be in D, e.g. it can be in R A D radians, or it can be in G R A D gradients. This is by far the most useless one for us right now. And in CXC maths, all we use is degrees for the people. Degrees, D. 7.9. Wow, Daryl flying through. So I have messages from Red Group. A lot of messages from Red Group. I needed the positive eye, so I shared it. Thanks, it was greatly needed. Sine 8 things. Alright, so that's one before. Sajda come true. Danny come true. Danny again. Quick on this boy. Red Group. 7.96. So Sajda, Danny, and Anne from Red Group just spelled out some answers there. No one has seen a missing Isaiah. What's going on? I'm not saying that thanks. Yo. Same thing. Okay. If you're still getting problems, let me know. Daryl. I'm looking to see, try and get the same answer. People get 7.96. Everybody getting a 7.96. And looking good. Liz starting to touch down there. Is Liz who said she was coming home and leave home or something like that? I'll wait for a couple more answers. Mercy, I'm really waiting to see your answer. Mercia. Photo EG. You're making it look like pages scarce across by you, boy. But anyhow, the thing looking good. And you're really getting non-cursive. I don't know if EG is again. But you're really getting non-cursive in that sign, boy. What? Mel, that go work. Oh, Jada, yo, that go work. Finally, Blue Group starting to come alive. Karina. Good. I see enough. I didn't see what I want to see. Still getting problems? Let me know specifically where you get any problems. Someone is typing. Alright, so we gotta move forward. You know, it's done. What's the time already? It's done 8 o'clock already. Time, so we don't have the sine rule perfect. Some people have it kind of good, but we don't have it perfect yet. Cosine rule, time to bring in new thing. Because you're in maths when you're now starting to get something, boom, new thing come out. Cosine rule. So the cosine rule is another rule. This rule is by far one of the most complicated formula, not by far. This is the most complicated formula. Yeah, it's one of the most complicated formulas you'll use, or most problematic formula. If, as a math teacher, I have to rate the most problematic formula for CXC, might be this one. Other than the completing the square, some students get whack on that. This will be a C. So this is how this works. C squared is equal to A squared plus B squared minus 2AB. Hopefully I remember the right thing, cos capital C. Let me get the exact formula that CXC have. What is the exact formula CXC have? They may have the A, B, and C in different places. No, this is the exact formula they have. This is the exact formula. So we living out here. Blue Group just sending some more stuff. Crystal, what happened in here? Let me check this. You have the correct setting though. But why you have the wrong answer? Check what your calculator is in. What is your calculator in? Some people calculate not in the right setting, evidently, because they have the right working, or they probably typing it wrong somehow. Remember to go back and check in the video when you're done if you're getting problems with how I typed it into the calculator, okay? Let's keep going, let's keep going. Why maths was created? Some people are real vexed with this topic, but so yeah, so there's a cosine rule here. There's a cosine rule here. So let me leave sine behind for now. It's not why maths was created, it's created maths that was. There you go, yeah. Maths is an expression of nature. C squared is equal to a squared plus b squared. Rain started falling here for real, boy. Gosh, that's a sign or something. C squared is equal to a squared plus b squared. This one must go come in here and trying to do thing, trying to make me remember the old days. Y'all will let me know if the audio get whack because of the rain. So c squared is equal to a squared plus b squared. How does this work? Now, as weird as this formula is, it's pretty easy to spot when they want you to do this formula. So I'll go ahead and show you already. One time. If you have A and B and capital C, and maybe you're trying to find common C, most of the time this is the one you're trying to find, that is when you use this formula. So this formula is easy to spot because I'm going to remove the letters and put numbers. Let's say this was 10, and this was 11, and they gave you this angle as 40 degrees, and they ask you to find x. That is when you go in your back pocket and you bring out the cosine rule and you blah. Hey, don't walk with nothing in your back pocket. So, cosine rule, when you have two sides and an angle in between, just like how you would use the area formula if you'd watched that video, half AB sine C. Very similar to that. Anyway, so this is your cosine rule. So let's use the cosine rule one time on this. One time. So I would throw down the labels because it seemed like this is looking nice. I would put C here, capital C is on the next side. Any comments? Any comments? A, B. It doesn't matter. I could put A, but just try that. I could put A, B here too. It just depends on what we're feeling like, what our date is, or where they have it in the question. See that when you pick it no, it doesn't have any way to label the triangle. You label what you want. But if you have the angle here, I would always call this one C since the formula works with Sine. But you can actually rewrite this formula saying this as A and this is C squared plus B squared minus 2CB. Excuse me, you understand? But stick with the status quo. Alright, so let's do the substitution. X is equal to A is 10 squared to B squared, and B is 11 to B squared. Take away 2 by AB, 10 by 11, cos of C is 40 degrees. Any questions with that substitution? Stop taking that substitution, make sure you're feeling comfortable about it. Hey, I need to focus on my handwriting. See when I start to get excited, handwriting start to going out. My head is in already. I just stay focused, we're doing this. So I want to just move this question across here. And move the diagram above me. Move this. Why is in the chat if you're following, you're relatively following so far? All we did was a substitution. C is X, that's what we're trying to find. A and B are here respectively. So A, B, A, sorry, that's 2. That's pattern from A, B. And then 40 is the angle. So now you can actually put this entire thing in your calculator, but I don't advise doing that because everybody, not everybody, most people make a mistake right here. So this is the one of the times in maths I advise to do it part by part. So I will be like 10 squared plus 11 squared on my calculator. That is 221, right? But just to make sure, you're fighting sometime in maths exam, you would want your calculator to add 2 and 3 together just to make sure it's still 5. 10 squared plus 11 squared, 221. Right, good. So you put the 221 here. So we're done with this. Now you're going to put a subtract sign here, and you're going to deal with this whole thing here. You understand what I do, eh? I put the subtract sign first, eh? Put the subtract sign first, people. Will you hear me? Right? Cool. Good. Oh, I didn't see what I do. So I'm going to put the subtract sign here for that. And now I'm going to do this whole thing in my calculator. 2 by 10 by 11 cos of 40. I see some late nights coming trying to do this. Yeah, boy, this worksheet. You see how everybody was stunting on the last worksheet. Everybody need 80% and thing. A lot of people. I don't know when I have made this worksheet. I want to 2 by 10 by 11. And I just going forward, even if you do understand everything. But next week class, we might do a complete repeat of this class. So I just work on the whole thing on the calculator, but I forgot to show the calculator. So now I do it over. 2 by 10. You see how I'm using the brackets instead of putting multiply? 11, because I want to write it exactly like how I see it. Now it's cos 40 degrees. Close that up and just press equal, and I get 168. Now here, put in as many as you're feeling up to, because this is not the final answer yet now. So I like to put in everything. Let me show you what I was doing. I put in the whole long thing here. You know why? This is not the final answer. Only when I reach the final answer, I would finish. I'm going to sneak in a square there because remember c squared. So we're still going on with x squared, we're going on with x squared. See how long and laboring in the vineyard this question is. When you subtract these two things, 221 take away. I'm not showing the calculator this one because I mean everybody could subtract these two numbers. Now we're in free for all territory. 1, 2, 3 equals. I got 52. Why am I changing between black and red? 52.47. speaking it into existence. I'm gonna mash this worksheet up. Speak it, come on, speak it. Somebody on 52 already, long time, Ellen? Very good. But that's not the final answer. 0.2225. Because obviously this can be 52 and this is 10 and this is 11. Just not looking right. But yeah, fortunately for you, you have this x squared there. So it means that x is actually equal to the square root of, damn, I not really feeling to write this whole number again. See things I do for students. And now the square root of that. So I'm just going to write square root. Let me show you what I'll do. Let me show you this little trick. So I already have it here, and you see it showing right here in the calculator. So I want to find the square root of that, so I'll just write square root, boom, and use answer and press equal. So I find the square root of what was before. So now that is 7.24. And now I can round off to just put 7.24. Woo! When you're done that question, say woo! 7.24. So C is equal to 7.24. So if you need to take a screenshot of this, do it, because I'm just going to give you a question one time. We don't stick it. Again, the question one time. We're going to do a couple more questions on cosine rule. Then we're going to do angle of elevation. Then we're going to do bearings. We don't stick it. We keep on going. Even though something is still dark, you're still moving forward. Next week we'll do a whole recap on everything. And hopefully you'll be able to turn on some more lights and connect some more pathways in your brain so everything started to come together a little more. When I done and old enough, I'm gonna burn all my math stuff. Wow, so drastic, so dramatic. Next time we become a math teacher, boy, we'll just go back and watch these comments. Good. Time for the new question. Zap, zoop. Let's say this was 3.0. Let's say this is 4.6. And let's use meters. Let's use meters. Let's say this is P, because we're feeling to call it P now. And let's say this is 36 degrees. I'll give you one more question after this. Find P, people. Find P. Proceed. Let me see if anybody getting this one out. Let me see if red group will still be shining like how they were shining earlier tonight. Red group for the people then. Warriors playing tonight, right? Warriors are that. Warriors need that bush practice. Right, so that's what before. Danny's still sending, there's no one but sending positive things in red group to keep the morale high. Matthew, and so looking a little suspect there. This one has done better. Mercia. Good. Is this good? This is good. This is good. This is progress. Alright, so we're waiting on the answer for this. Time to start you all off. Time to start you all off. Let me see if Christian's making smart talks in the chat there. Or William Maths book and thing. Yeah, 3.0. 3.0. Sorry about that. 3.0. So find P. So we're good. First thing first, just write our formula. Label up everything. You know the side of the angle we'll call C, right? For sure. And this is common C. Or I can leave it as P, but I'm going with C. And we call this A and this is B. Some people might have this as A and this is B. That's totally fine. Start off with the formula. C squared, that's common here, is equal to A squared plus B squared, common, all common. If you mix up the common and the capital here, you're on foolishness. Minus 2AB cos of capital C. Now, hit the little substitution here. P squared is equal to A is 3.0 is the same as 4.6 squared. Maybe I shouldn't do any more. Maybe I should wait. Anybody thoughts in anything yet? Red group, blue group, red group, blue group. Still waiting, minus 2 by, I'll put brackets here to help me, 4.6 and cos of 36. Cos of 36. Now I'm going to do it part by part. Here comes blue group. Quickly. Well done, Mel. Mel for the people. Mel get 2.8, and I kind of like the sum of that. That's something correct. But there's just one. Let's see if you was correct. You use 2 significant figures. You should use 3. You just have to be careful with this. Use 3 significant figures. In CXC, when you solve this, you're going to use that value very likely to do something else. So you need to use significant figures, game on point. Otherwise, your answer will start to get little small errors. And when you come on the exam, you can say, I get 7.1, and somebody says, no, I get 7.23. And you'll be like, 2.80. Okay. Sabrina sent something and deleted it real fast. 2.79. Danny is sticking to the script and using the 2.08. I definitely want to do this one and see who's significant figures are the closest. See how all the answers have a little kind of difference there? Let's see which one is the best answer. Best answer. So I'm doing my 3 squared plus 4.6 squared. How much is 4.6 squared? Like, close to, close to 10. But this is giving me 30. Woo! People are else saying anything here, but more than the sine rule. They love this rule, but you need to do an next one of this. 30.16. 2 by 3 by 4.6 cos of 36. Maybe you all should see what I'm doing here. Yeah, that's what I'm doing. Cos of 36. That's the next part already. Do the first part. Okay, and now I advise you to write out the full long thing here. That's just me. Or you can take my advice, as the teacher here. Or you can just write a short thing here if you're feeling like it. I advise you to write out the whole thing. Like that. And now I'm going to use the little answer shortcut. I'm going to say 30.16 subtract answer is, and I have this 7.831130955. Just numbers, it's just numbers. No need to be afraid of big numbers or long numbers. That's p squared. So p is going to be equal to the square root of that. The square root of 7.831130955. So I'm going to use the shortcut again. I'm going to say square root of answer is equal to 2.798. All right, all of that. And now I'm going to come and say like 2.80 to 3 significant figures. And now see why it was giving little problems. Earlier. So when you use 3 significant figures, this one will round up and it will turn to 10. So you get 0 there and you bring the 1 there, so it's 2.80. So the 2.80 answers is the best answers. That's why some people just have straight up 2.8. But if you put in 2.8, you need to put a 0 to show that you use 3 significant figures. 2.80. There's some problems there. Some people, you're seeing the problems. You're seeing the problems. You're seeing the problems. Danny just said it means. And you don't click on Danny photo, it's falling up your phone. Nah, but she's sending positive things. 2.79. 2.79 is wrong. They might give that answer correct still, but you're really seeing when you round off, it should be 2.80. Alright, next question. One more. One more, boy? Nah, we're not doing one more. This. So a lot of people get it out. So what we're going to do is angle of elevation. So we're going to talk about angle of elevation. Then we're going to talk about bearings. Then I'm going to tell you where your homework will be. Part of your homework will be reviewing videos, watching over this video over and over, getting it in your system. So that when we come back next week, everybody must be starring, because next week we'll be doing past papers on this. The best way to learn these questions is in actual past papers, seeing. It'll be a little more complex than just straight up triangles now. So you'll get past paper style questions on this next week. Let's go on angle of elevation. Angle of elevation talks about, it's pretty simple. It's going back to the land of triangles. Let's see. I feel like I talked about this already. Oh no, I do this in my physical class. Let's see you. Let me do some drawing here, people. This is a cliff. This is water. This over here is a boat. Okay. This is a fish swimming on top of the water. I don't want to draw no boat today. Right. This will be given in your exams. Let me say this is 11 meters. This could be given as well. Or let's say that's not given and they want to find each, the height of the cliff. Then they will give you the angle of elevation of the top of the cliff from the fish. So they mightn't draw it, they mightn't do none of the, oh, you're not seeing the H, sorry. The H is on this side, right? So there's the height there. Let me see the comments, just in case somebody have a little question or how much. 43 people online, so we starting to be back to the normal numbers here. Just half an hour to go, and I feel like we need real time again. That's such a nice fish. Thank you. So, we'll see. I see give the sine and cosine rule on the formula sheet. Of course, they always do. It will be there. Where are you going with this? I have questions. Please answer me, please, Sabrina. So, with the sine rule, and no I was sensing a question. So, if you answer like 0.1 off, will it still be correct? You may lose a mark if it's outside the range of questions. The one correct. Jada Ismail. Okay. Move the calculator. No problem. And I have questions. Please answer me, please. But I'm not seeing the questions, so you had to rephrase. You had to provide the questions. And I want to move this diagram a little bit to the side because I'm kind of blocking it. So yeah, what we're talking about here is angle of elevation. Going on here, going. I just want to see like the diagram and open it. So we have a cliff, we have a fish away, and we have the height given there. And they would say like the angle of elevation from the top of the cliff through the fish. Angle of elevation of cliff from fish. Handwriting though. Angle of elevation of cliff from fish. They might say that is equal to 40 degrees. And they will ask you to find the height of the cliff. Now these questions typically, can't see it good, please move the diagram over and move it over. So you skip over my question, Sahana had a question. So we only doing elevation, we're doing everything. Elevation, depression, and hopefully bearings, we get touched that too. The angle is under the horizontal line. Very good, Giovanni. Can't see it good. I tell nothing to see. It's just a fish. You can even ignore this too. I just write it for kicks. But they will tell you the angle of elevation is, how much I say, 40 degrees. So, and find each. So what you need to do is come on, make a quick little sketch diagram. You don't need to draw no fish or nothing. And the angle of elevation is always the angle that the hypotenuse makes with the horizontal. The angle of depression is equal to the angle of elevation. It doesn't matter. This angle here, let's call him theta. They said it was 40 degrees, so I'm going to put 40 degrees. By they, I mean me. So I said it was 40 degrees. It's going to be 40 degrees. That angle there would be equal to the angle of depression, which is like this angle over here, which is 40 degrees as well. So it depends on what they give you in the question, what kind of question they're asking you about. Angle of elevation and angle of depression is the same, is one and the same thing you're always talking about. Same style of working. Angle of depression just has to do with the one that's going down, and angle of elevation has to do with the angle that's going up. But if you really think about it, this is the same kind of Z thing. The angle of elevation, this one, is the corresponding angle to the angle of depression. That one is the same Z thing that we did, the first thing we do when we touch trigonometry. So that is that. Any more questions? Can't see the horizontal, the angle is under the horizon. This one is new for me. All right. Yeah. So how do you solve this? This is back to easy thing. This is back to the thing that you all crushed last week. This is the SOHCAHTOA stuff. Let's get rid of this since we talking about elevation here. They ask to find the value of each. The value of each. So you're supposed to see now that this is just a triangle. It is a right angle triangle. When you deal with angle of elevation and depression, it's right angle triangle, right angle triangles you're dealing with. So you see how you say this is a new one for you? This is actually an old one in new clothes. It's the same thing you're doing, it's just wearing on a different clothes. Right? Wearing on different clothes. So this is the same thing. So what rule we gonna use? Yes, very good, Darren. So this is opposite and this is adjacent. So you're gonna tell yourself, yo, we try to find h. They gave us the adjacent. We know nothing about the hypotenuse, and most times in angle of elevation, it doesn't know anything about the hypotenuse. So most of the time it's using tan theta, tan, because it's always opposite and adjacent. You use it. Most of the times, sometimes it could be different. Enough talk, time for action. Tan theta is opposite over adjacent. The theta is, time to send this diagram back over my head. Let's say over my head. Bring this tan theta up a little bit so I can get some room to write. Tan of 40, and from here on out, you're just supposed to activate your SOHCAHTOA skills here. 11, the thing we're trying to find on top, so h will be 11 times tan of 40. Boom. 11 times tan of 40 is something. You would put your calculator, you do that, and you get 9.23. 9.23. All right. Them saying is 9.23. So I will believe them. 9.23 meters. Boom. Solved. So why is in the chat if you understand angle of elevation? It's good to be back into simple formulas. Good to be back after that sine rule and cosine rule. Take you for a nice little tango. It's good to be back in the angle of elevation. I hope you're ready because bearings is just going to take you back out. We're going to end off in bearings. That's going to be a drama. The drama seen in bearings is that bearings uses, let me just pull up a quick question. Bearings uses, I wouldn't pull up a quick question. I guess learn by fire in the assignment. Bearings uses everything in trigonometry. You could guess Pythagoras theorem, you could get SOHCAHTOA, you could get sine rule and cosine rule pop it up for sure. It's rough. Next week for bearings. Nah, this week. Even if I just tips it, I want to include it in the assignment so that I struggle. And I always do it here. There must be some struggle for the students. Otherwise, if I'm spoon feeding you, you are not learning. Spoon feeding is just an initial thing that you want to do to break down some hard concepts. And then after that, you need to struggle. And you need to struggle with help. So I need to be like there to pull you out if you're drugging. You know, come along. Looking good halfway drugging there. Keep coming. So it's basically tan, sine, and cos. Yes, it's basically that. Let's do a question very quickly. So, the last piece in the mind. So we have this post here. Well, you ever see center of excellence, flat pole. Let me say we have a pole, and there's a flat pole here. Now I'm going to give you some very hard questions. It's not going to be like what you're seeing here. Some will be like that, and some will be testing you a little further on. So you'll have some research to do. This week's assignment is going to be one of the toughest assignments. Probably the toughest assignment in the whole 22 classes we have done so far. So let me just tell you that one time. Let's say there's the flagpole makes a shadow on the ground. And the shadow, somebody measured the shadow, you understand? They measured the shadow with, I don't know, some kind of long tape or something, and the shadow turned out to be 20 meters. And now they use one of them surveying kind of protractors that shows you the angle of the angle of elevation and the angle of elevation of the post elevation. I'm not going to draw it because I want you to, draw it. Angle of elevation on the post turned out to be 47 degrees. When you use the angle of elevation tool to get 47 degrees from the point P, right? From that point P on the ground. Most of the times they like to call this point O, and they might call the post maybe MN or something like that. Or they wouldn't say anything, they would just say find the height of the post. So you have enough information there. Find height of pole. We near the end of the class, I just saw my handwriting. My handwriting we tire about, but it's you can read it. It's legible. Find height of pole. Great. So find the height of the pole. Proceed. Eight 37. Yeah, we have time. Having the time. So after this, I'll show you a quick example of how the question and depression can come, and then I'm going to do some little talk on bearings, and we'll call that George. Nearly finished. We're gonna start back again. We call it a run, but like we ain't trying to save money from bearings. Find the height of the pole. So I'm going to call that H. I'm feeling to call that H. And once again, you see that is time we're going to be using. This is just elementary here. People send this in group already. You can send your answers right here in the chat. Send your answers right here in the chat. Everybody getting 21.4? That's a sign, no bearings. So yeah, so this is just going to be our next stand. Now sometimes they will ask you to find, sometimes instead of asking you to find the height, they will ask you to find the angle of elevation. And you know how to do that. So tan theta. Tan theta is opposite over theta. For example, what you would do if they did not give this, if they was asking to find that, and the height, they gave the height as 10. Well then just put 10 over this, and you have theta, and then you have to find the tan inverse and stuff like that, right? So keep that in mind. You're going to get questions like that popping up at you. Tan theta is equal to opposite over this. And the questions will come very likely. The assignment will pop tomorrow. Tan theta is equal to theta is equal to opposite over this. And theta is equal to so tan 47 equal to opposite h over 20. Sometimes they wouldn't ask you to find this, they will ask you to find this one. Anytime you start to get a topic and a question from now on and starting to get stronger in maths, you need to start thinking how they will ask me, what they will ask me. Okay, maybe they might not ask that, they might ask this, and let your brain think on it. That will help. I always think in an exam mode. Always be in exam mode. Don't be in study mode. Don't be in I'm trying to learn tan theta opposite. Always be in exam mode, like how to write this, how to write. It's about a matter of perspective. That's the learning perspective that a lot of people get wrong, and that's why you're feeling to break. Like some people always earn 70% in the assignment, and they keep asking me, sir, why I'm not getting higher than 70%? And when I send the top students, and some people seeing 100%, like how do these people get 100%? Always be in exam mode. Always be thinking, what can I be tested on? How can I be tested? And keep looking at it from that perspective. Instead of a perspective where you're trying to study and remember everything, look at a perspective of where you're trying to understand every question. I don't know if that makes sense. H is equal to 20. by tan 47, and people are saying that it's 21.4. I believe on it. 21.4 meters. Yeah, because this is very close to 45, and tan of 45 is 1. So therefore, it's nearly 1 by 20, which is it shouldn't change by much. Very quickly, let's look at what will happen if the rain stop. Well, yes, the rain's coming. If the rain start back, well, we might call it George. So they said, like it started with the rain dance. Angle of depression could come with just that same kind of setting. They like to bring a ship and a cliff and flat pole or a building. Let me use the building example. A building and a man is on top of the building. He's not going to jump. He's not going to jump. He's not doing cosine right now, so he's happy. The man on the building here, and he's looking down at, I don't know, a sign, and they want you to find. They may give you the angle of depression. The number one mistake people is making angle of depression and angle of elevation. Listen closely. The number one mistake people would make is putting the angle here. The angle does not go there. The angle of depression and elevation always goes to a horizontal line. So it's between the hypotenuse and the horizontal line. So if they told you the angle of depression is, you're going to get a question on this. I'm not going to do one right now. As I said, you're going to be fighting up this week. We're going to come in next week and start to explain all the errors and go through everything a little more. So this is 20 degrees. If this is 20 degrees, if this is the angle of depression, then when you start to work out your stuff, use 70 degrees here. Who can tell me why you're going to use 70 degrees here? If they give you the angle of depression, use 70 degrees as the angle inside. And yes, you are probably thinking it. You are correct. Because this whole thing is 90. Or if you're not feeling to use the 70 degrees there, you can come and put the angle over here now, 20 degrees as the angle here. And then work out whatever it is they want you to work out. If they gave you this as 100. Alright. Yes, correct. So why in the chat, if you understand angle of depression, elevation a little more, angle of elevation and depression, generally speaking, would use your SOHCAHTOA rules, mostly the tan. There is the case sometimes where you may end up using sine and cosine rule, and as we start to do more stuff and maybe in the crash course or something, you'll see where like a weird example could come. So you always need to keep your mind open. Keep your mind open. Very quickly now, let's talk about bearings. This is like a quick crash course in bearings. We have 15 minutes. Bearings tell you the location of something from something. So like if this is, they use tongues most of the time. If this is tongue A and this is tongue B, we want the bearing of tongue A from tongue B. It gives you a direction. The bearing just gives you a direction. So, and the magnitude of the direction. So you always point up to get your north. This might be bringing back some tough, painful memories to some people. Some people must be getting, let's call it post-traumatic stress, PTSD. Like, pain. You always take your bearings from the North Pole. So you need to draw north and do your angle. So I'm going to ask some simple questions just to make sure you understand the concept. So the bearing of, let's say this is 120. The bearing of B from E, the bearing of B from A is 120 degrees. Right? Simple, right? You take your north, measure your angle. You're not going to measure your angle in the exam. They will give you it and then start to ask you some whack questions on it. You would see one of the examples for your assignment. Some questions on it. Alright, let me ask you some questions. So what about if I had a tongue here, Z, and I have a tongue here, X. No, let me say tongue Y. And I'm going to give you the angles. This is naught. I'm going to put a naught here too, because I want to ask you something that students make a little mistake on all the time. And well, you know this has to be a reflex angle. So let me say this is 260 degrees. If that's 260, what is the bearing of Z from Y? Why is it called tongue? Tongue. 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 I know my pronunciation kind of what, but I mean tongue. T-O-W-N. We nearly finished, people. We nearly finished. Answer this question. What is the bearing of Z from Y? Come on, be bold. Pick them the answer there. What is the bearing of Z from Y? One person say 100. I ain't saying whether I'm wrong or right. I want some more people to answer. There are 39 people. A lot of people say 100. One person saying 260. One person saying revolution. Hey, Jamari here, man. A lot of people saying 100. Take it away from 360. Okay. All the 100 people wrong. All the 260 people still wrong. Bearings have a way of being very, 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 very simple, but very, very, very tricky. You can just make one mistake in what you're minusing and what you're taking away. Bearings are always clockwise, and you need to pay attention with the wording. Always clockwise. So you could probably just write on a page clockwise. Then take up the whole page. Anytime you're dealing with bearings, clockwise. So you need to start on the north and go this way. So it's somewhere like it should be 260, right? But the bearing of Z from Y. I specifically wrote it like this because I wanted you all to make this mistake. The bearing of Z from Y. The one where the word from is the one you need to look at. If I ask you to come from there, where you're going to start off? From where you are at. Come from in the bedroom to the living room. It means you need to come from the bedroom. So if I want the bearing of Z from Y, it means I'm talking about Y. I'm talking about Y. Where is Z located from Y? So you need to start at Y. It's not 360 taking away 260. It's not that. Nobody has the correct answer yet. So let's put it in the diagram first to see if we can figure it out. So the bearing of Z from Y, you're starting at the north and you're going clockwise until you meet the line that connects the two. So this is what we want to find here, this angle. Do we have enough information to find that angle? That's where you need to start to ask yourself now. One person saying 45, that's not correct. I don't know if anybody already correct answer it. Let me scroll up and see. I don't think so. It's not 45. So we know what we're looking for now. We realize that we need to look at the Y. That was a decoy. You need to watch the one that they said from. The bearing of Z from Y. Look at Y. Where is Z located from Y? One person saying 90. That's somewhere a little better, but it's not correct still. So you want this angle here. So now you need to use You need to start to get frantic and use all the knowledge that you have of trigonometry and these cutting lines and all kind of things from before. What is one of the tricks that really helps in bearings is extending lines. If I extend this line here, you'd realize that this knot and this knot makes it like a parallel. It means that this angle is corresponding to this angle. We go in places. We go in places. So we can start to figure out what this angle is here. Anybody? Shania. Shania. Is she on the right track here, boy? I think Shania got the answer here. Yeah, I think Shania got the answer here. 20 people left. Yeah. We can see when I do the minus. So this is corresponding to that. It still may not be apparent to you how we're going to find the angle. How are we going to find the angle, boy? And by the way, bearing is, even though you have 80, you'll put 0, 80, because you normally write it like that. You know that? I just the way to write it. How did we get this angle here? Well, if you put on your glasses and look very carefully, very, very carefully, you'll realize that this is a straight line. Looking very carefully, right? This has to be a straight line. So it means that this angle here, angles on a straight line, is 180 degrees. This angle, this first piece of this 260 is 180 degrees. It means this angle here, if I label him theta, theta is actually equal to the given angle, which is 260 degrees, take away 180, which is equal to 80 degrees. Yeah. So you see how simple but deceptive it is. It's like female. No, sorry, bad joke. But it's very deceptive. It's very deceptive. It looks simple. The bearing of z from y looked like a very innocent question. You know, what's the bearing of z from y? But yet you had to go and do some calculations and corresponding angles have to come into play and thing here. Right? So since this is 80 and it's always had to get a reason, you use the corresponding angle and this must be 80 as well. Alright, hopefully people seeing a little more light here. Let's do a next question. And what they will do in your exam is give you 3 terms. We wouldn't be able to do the entire question now because they'll ask you all kind of whack stuff. But after the crash course and thing, I'm hoping that you're in a really good place, even if you're not strong in maths. Like you can make it. You can watch yourself in the mirror and say, yo, I believe in you. We're going to do this. We can make it. So I'm doing you the favor and connecting up the points one time. Because we just talking here. We just talking. We're actually putting pen to paper that much. And so let's say let's call them town T-O-W-N, town ABC, and let's say the bearing of B from A is, what are looking like, man? 175, and let's say C, it's not looking so let me just straighten them out a little bit. I need to straighten out a little bit there, fellas. Bram. Let's say C is to the east. So C is east of A. And they love to use them kind of terms. They will say this is east or this is west. C is east of A. Bearings is critical thinking. I do think it have a more topic in a better topic in maths where you need to use critical thinking. But bearing is be sit down or circle geometry. Circle geometry. A lot of that too, yeah. They just be sit down like, what it is I'm trying to get here. So that's a good point, Anne. So let me start to ask questions. What is the bearing? This is an easy question. I think I just gave the answer. Maybe I did. What is the bearing of B from E? So what is the bearing of B from E? Bearing of B from E. So that's part E. What is the bearing of E from B? Now don't feel like how if you can figure it out, it's a little complex. I need to get this out of the way, out of the plain sight. Sometimes I just forget to write properly now. What is the bearing of B from E? B equal 5. Nothing here equal 5. This is 175. Right? That's all I was given. And the next information I was given is that C is east away. With that information, you're able to figure out everything on this diagram in terms of angles. So, right. So you're correct with that diagram. So the bearing of B from E, what is the bearing of B from E? It's 175. You always need to watch the word from A. So we want B from A, so we need to look at A. And that's given, that's 175. Great, we have that. So this is 175. We're going to finish now. What is the bearing of A from B? That's A from B. I'm helping you out here because it's just 3 minutes. A from B means we're watching B and we're starting out and we're going clockwise. So don't think it's this angle we get in here. We need to always go this direction. All the way until we reach the line that connects them. Boom. So that's very close to 360 degrees. How are we going to figure out what that is? We need to extend. Extend, extend, extend. Always looking at extension. Extension. You know, like they always be extending time on assignments to make sure that people still get marked and things because people missing the Sunday deadline. So we extended. How did that help us? That helped us because we could figure out this little tiny angle here. You see now? If this is 175, it means that this tiny angle here must be 5. Because they need to go up to 180 degrees. It means that this angle here as well, anybody figure this out? Must be 5. I'm not going to say the answer yet. I'm waiting to see if anybody will pull it out of the hat. So the bearing of A from B, what do you think it's going to be? Right? So we get that 5, but it's not 5 because you can't see this way. You need to go the other way. So what is the bearing of A from B? Very quickly. 355. Well done. Because an entire circle will be 360. So since you're 5 degrees short, it's 355. The bearing of A from B is 355. And very quickly before we go, I'll just talk about this. I want to ask. They can ask you what the bearing of C is from A. From A, the bearing of C will be, well, it's starting on A from A, so it will be this way. Now, since it's east, anytime you're using cardinal points, it'll be at 90 degrees to each other. So if this is east, it means the bearing of C from A is 90 degrees. So if they ask C from A, this was 365, this was 090, meaning 90 degrees. Or if they ask what is the bearing of A from C, that's going to be this way. And we know this is 90, so it has to be 270. Where they are going to lose off 90% of the people who are doing maths for CXC is when they start to ask you about C and B. Like what is the bearing of maybe C from B? And that will start to involve little calculations. May start to involve little calculations. Where you would use this angle in your triangle, this angle in your triangle, find out the missing angle here, time is up, find out the missing angle there, and take it away from 270. So it's going to be a little tricky. This is the part of maths that gets this. You shouldn't feel despondent or discouraged, this is like the hardest, one of the hardest topics in mathematics here, bearings. You know that bearings, the ending of matrices, circle geometry, completing the square, linear programming, those are like the hard topics in mathematics. Bearings is like one of the hardest, right? So if you're struggling to understand it, don't worry. Keep plugging. When the worksheet comes, be ready for it. Give it your best shot. You're going to get, at the end of this chat, at the end of this video, I will send the videos I did online on bearings and angle of elevation. So you can watch the whole thing at your convenience during the week, tomorrow, day after tomorrow, Friday. And get something to work along with for the assignment. So good luck in the assignment. In the assignment, you're going to get everything we do here. You may get CXC type questions as well. Questions to see how well you understand it. If you get total in this assignment, that would be amazing. So try your best to get total in the assignment. It's going to be a little challenge. Anyhow, enough talk. Enjoy the rest of your night. This was an exceptionally hard night because I was drained and tired, but you know, sometimes you have to do things that's really tough to get the results you want. And I want people to do really good in this class. Good night, everybody. Danny, thank you very much for the positive text. It, you know, raise the spirit. Ready for this homework. So we're doing this over next week. Yeah, we're doing over this entire topic next week. Right, good soon. I'll go on with that one. I'll try my best.